Okay, now we're talking about mechanical energy. Now, mechanical energy is energy due to position, condition, or motion. In other words, how something is, what's acting on it, and if it's moving or not in mechanical energy. Now, there's a lot of different types of energy that we will cover later in here. Like, for example, electromagnetism. We'll find out electricity and magnetism are similar. They go hand in hand. We can also have thermal energy, not covered as much in this course, but it is a type of energy. Atomic or nuclear energy is almost exclusively the world of chemistry until we get to another. And we're going to focus wave energy. We'll spend a lot more time on that later. What we're talking right now is just mechanical. Now, mechanical energy is not a new thing to you. It's one of the types of energy you've learned about before. Kinetic and potential. Now, kinetic energy is action energy. It's energy in motion. It's something that's happening. Potential energy, potential means stored, so we're talking stored energy. Now, in action energy, kinetic energy, we're going to use the letter K for it. And the formula is 1/2 mass times speed squared. An important thing to understand with that, kinetic energy can never be negative. Because mass can never be negative. And if you square a value, even if it is negative, it's going to come out positive. So kinetic energy in the mechanical world involves objects moving. If V is equal to 0, then K is equal to 0. You don't have any energy unless you're moving. Now, potential energy, there's two different types. There's gravitational potential energy. Gravitational potential energy is based on where is an object located in a gravitational field. And then there's also elastic potential energy. And elastic potential energy means you have something that's stretchy. Now, for gravitational potential energy and for elastic potential, we'll use the letter U. You also may see it sometimes written as PE or P, but we're going to stick to U. U is kind of what the chemistry people use, and we're kind of gradually winning over to that. So for gravitational potential energy, we'll say UG. Well, UG is equal to M times G times H. M is mass, G is the acceleration due to gravity, 10 meters per second squared, and H is the height above our reference point. More on that in just a minute. Now, elastic potential energy is involving things that are springy. Springs obviously are the most common place we see it, but anything that has some type of elastic or the ability to snap back. For that, we'll use U and elastic. Sometimes you'll see people write US for U of a spring. I like E for elastic because it's more generic. That's equal to 1/2 K times X squared. K is a spring constant. It's different for every spring in the world. And X is your displacement from rest. And again, more on that later. We have a lab on that coming too. So let's take a look at units real quick. The units for kinetic energy. Well, it's 1/2 mass times speed squared. Well, 1/2 is just a constant to make it work. Mass is going to be in kilograms. Velocity is going to be in meters per second, but then it's squared. So I get kilograms times meters divided by S times S. Well, if I put these together, let me slide it up some. That's what we call a Newton. A Newton times a meter. A Newton times a meter is also called a joule. So our unit will be joule, named after a British physicist who did some work with energy, and so we inducted him in the Unit Hall of Fame. Now, for this one up here, let's take a look at units. U is equal to M times G times H. Well, mass is in kilograms, G is in meters per second squared, and H is in meters. Well, that's a Newton, that's a meter, so it's also in joules. Now for spring energy, and this may not be because we don't do it quite as much. 1/2, again, is a constant to make it work out. K is going to be newtons per meter. Distance is going to be m squared. When you do that, one of your m's cancels out, and we're left with newtons times meters again, which is a joule. Now, big thing to understand is energy must be conserved. Energy is conserved. Except in very, 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 very rare circumstances. When we split atoms or fuse atoms, then energy can be gained. It's created from mass by that equation that everybody knows, E is equal to mc squared. We're not actually going to do this right now. We're going to say that all energy is conserved, and we'll have another video on that. So types of mechanical energy right now, we're focusing on kinetic energy and potential energy. Potential energy has two types, gravitational and elastic energy, and then how those three interact. The next video will help you talk a little bit about conservation of energy in greater detail using energy graphs. Hope this helped.